I'm going to give you a minute to copy how is an arc named and what is the measure of an arc, and then we'll go through and of course copy this picture down using one of your cutouts, and we will go through and discuss naming an arc, measuring the central angle, all of that. So go ahead and pause the video and get all this information down, and then leave enough room so that we can give some examples of naming each type of arc and finding the measure of certain arcs. Okay, so an arc is just a portion of the circle around the outside of the circle, and its measure is the same as the central angle. These are all central angles. BFC is a central angle, CFD is a central angle, DFE is a central angle. Arcs are just a portion of the outside of the circle. So arc BC, this is an arc, this is an arc, this is an arc. They're portions of the outsides of the circle. So the central angle determines the measure of the arc. So real easy here, we have central angle AFE is 63 degrees. That means the arc is also 63 degrees. And to name an arc, if it's less than 180 degrees, we would use 2 points. So let's look back at this arc AE. You use 2 points and then you use the symbol for arc. So another example could be BD. So from B to D is less than 180, so we only need 2 points to represent that arc. But if we're talking about a major arc, or an arc equal to or greater than 180 degrees, we have to use 3 points, because if I were to go from B all the way around to A, and I just named it as BA, there has to be a way to distinguish whether it's the bigger BA, so B to A, or the littler BA, so this B to A. So that's why if it's greater than 180, we use 3 points, and that tells us that we're not using the little arc. And if it's less than 180, we use 2 points. So then if it was BA, I would know it's just B to A. So if I'm going to name this arc B all the way to A, I'm going around the circle and I'm using the points in the order of which they're given. So I can say B to D to A. This could be arc BDA, or it could be arc BCA, or BEA, etc. As long as you're using 3 points and the 2 end points are the start and the finish of your arc. Another example is that if you have a semicircle, so that's half a circle. So this arc right here from B all the way to C, I'm sorry, from A all the way to C, I would use 3 points to name it as well. So I can name the semicircle A, B, C, or arc A, B, C. Now let's talk about central angles and the measure of an arc. The measure of an arc is the same as the measure of the central angle. So as I said before, since central angle AFE is 63 degrees, then arc AE would be 63 degrees. That doesn't mean the distance of the arc, it means the measure of the arc, which just means if I were to have an arc this big, how can I draw my central angle? Another way that you're going to have to solve a circle is figure out what all of the missing central angles are. So when you're given something like this, you always want to look for the diameters, because you know that a diameter is half a circle or 180 degrees. So these two together, these two arcs together will equal 180 degrees. So let's say that I wanted to find the measure of arc AB, minor arc AB. Well, arc AB would be 180 degrees minus what's already been taken of that 180, which is 63. So arc AB would be what's left over of 180 degrees, or 117 degrees. Okay, another example. Let's say I wanted to find arc DB, minor arc DB. Well, if these two arcs together are 180 degrees, because this is a semicircle here, and 90 degrees has already been used, then 180 minus 90 would leave 90 degrees for arc DB. Okay, now I'd like for you to pause the video and find the measure of arc AED, the measure of arc AEC, and the measure of arc ADB. So you'll have three answers that you should be responding with. Go ahead and pause the video and see if you get the same thing as I do. Okay, so we should have gotten 153, 180, and 243. If those are not the answers that you got, go ahead and pause the video. Go ahead and raise your hand, sorry. Okay, our next question is, how do you find the distance around a circle? And just as we said that length and distance are the same thing in terms of the distance formula, circumference and distance around a circle are the same thing. So circumference of a circle equals pi times the diameter of a circle, or circumference equals pi times diameter. This is the abbreviation for those two. And that just means, just like perimeter of the circle. How far around is the circle? We would use this formula. So example would be, find the distance around a circle with radius of 5 centimeters. Well, they gave us the radius, and our formula says circumference equals pi times diameter. But if you have a circle, the radius is going to be half of the diameter. The diameter is 2 radii. So if the radius is 5, then the diameter from one endpoint of the circle to the other is 10. So the circumference of the circle would be pi times 10. So when you're using your calculators, you can put pi in your calculator, and there is a button for that. It's the second button along with the arrow up, and that gives us pi times our diameter, which is 10. And for these problems, we will normally round to the nearest tenths or hundredths, depending on the question itself. For this one, we'll just go ahead and round to the nearest tenths. So circumference is 31.4, and it would be centimeters. So now we're actually going to take it up a little bit further, because I know that you've done circumference before. I think it was in 6th, 7th, and 8th grade you will work with circumference. But we want to be a little bit more specific and talk about not the entire circle, but what if you want just the length of an arc? So not a whole circle, but just a portion of a circle. And this is another formula that you will have to learn. What you do is you figure out how much of the circle you have out of 360. That's the arc measure. So let's just say that you had 65 degrees out of the 360 total. The arc length, which we can call this x, would be a ratio of pi times the diameter, or a ratio of the entire circumference. So let's see this in an example. So again, take one of your cutouts, copy this example down. Okay, and you will have to memorize this formula. There's no way around it. So we start with, how much of the circle do we have out of 360? So I always do this. I write 360 on the denominator, and then I write pi times diameter on the denominator of my second half of my ratio. Because I'm trying to figure out how much out of 360 do I have, and how much out of the total circumference do I have. So the easy part is, if I'm looking for zy, I have 75 degrees out of 360 possible. I know the diameter, it's twice the radius, so it would be 8. And what I'm looking for is the total arc length, the missing part, which would be x. And then I just cross multiply. So 360 times x equals, and I can just type all this in, 75 times pi times the diameter, which is 8. So all of that is 1884.9, we'll say 556. And then we would just need to divide by 360. And we would get 5.24 because it said round to the nearest hundredths. So our arc length would be 5.24. And that makes sense because the circumference is pi times 8, which is 25. So they're saying the entire length of this circle is 25, but just this part is 5.24, or 75 over 360 of this circle is 5.24. Okay, so that's the formula, and that's all it takes to get the answer to find arc length. So I'd like for you to try this next example on your own. Find the length of arc ZY, and we're going to round to the nearest hundredth. So pause the video and see if you get the same answer as I do. Okay, and you should have gotten that the arc length of ZY is 11.34 centimeters. If you didn't, raise your hand and we'll be happy to help you.